As quickly as it started, the eruption begins to die down.
We are just reached the end, and the tephra cloud reaches several kilometers high and is being transported by the wind over the city surrounding Etna towards the northeast side of Etna. And the eruption now, as you can see, is suddenly dropping after the paroxysm, and we may expect a series of powerful explosions when the conduits become cleared and blocked with lava blocks and cleared again and so on.
"40 minutes after the first explosion, the eruption is over. The pressure underneath the magma has eased and will take several days to build up again. Fortunately, the wind dispersed the tephra cloud, and the lava flows didn't reach the lower flanks of the mountain. This eruption didn't threaten any of the towns or villages below. System Poseidon is pleased because their forecast was accurate. Etna may be Europe's largest volcano, but by some standards, it's puny. This is Kilauea, on the Big Island of Hawaii. It's the largest and most active volcano on Earth. This volcano produces more gas and erupts more basalt lava than any other. It has built the island of Hawaii, the biggest single structure on Earth. It rises 32,000 feet from the floor of the Pacific Ocean. Kilauea is also the most studied volcano on the planet, the ultimate natural laboratory. The river of lava that flows beneath this crust is over 1,000 degrees centigrade and gives off deadly sulfurous fumes. These volcanologists are here to measure the size of the lava flows and collect fresh samples. They know the dangers of working here and accept the risk. One false step could mean instant death. The samples are cooled to solid basalt, ready for analysis back in the laboratory. The chemical composition of this lava reveals that it is a primitive rock, originating at a very deep level inside the Earth. Kilauea is known as a hotspot volcano. It lies above a stationary source of heat deep within the Earth's mantle, possibly as deep as 450 miles. As magma rises up to the surface, it meets the Pacific Ocean floor, moving slowly northwest. A series of volcanic islands grow above the hotspot. The Big Island of Hawaii is the youngest island in the chain. Basalt lava has been erupting in the Hawaiian Islands for over 5 million years. This lava is identical to the lava that would have spewed out onto the surface of our young planet 4 billion years ago. Basalt is the most fluid type of lava, and it can flow for miles until it reaches the coast. The island of Hawaii is still growing as new lava pours into the ocean. This is where land and ocean meet. where biologist Richard Pyle and a team from the University of Hawaii are risking their lives to study the impact of new lava flows on the marine environment.
Where the lava enters the sea, there's a lot of volatility, and depending on the sea surface conditions, there can be tremendous explosions right at the sea surface. Those explosions hurl large chunks of rock out into the water. And if we're too shallow and up underneath that rim of explosion, we might have large boulders raining down from above where we're not expecting them to come from. The sound is impressive not only because you hear it in your ears, but because you feel it in your body, and your lungs act as a resonating chamber.
As the molten rock surges forward, it forms what are known as pillow lavas. At the face of each pillow, an orange crack appears and quickly turns black. It's just a skin. Inside, the lava is still molten.
Occasionally, for reasons we don't quite understand, you see these pillow lava formations unfolding and getting larger, and then they suddenly implode. And no one's exactly sure what causes those sort of implosions, but it might have to do with water trapped inside, forming a steam pocket that suddenly implodes under either the water pressure or under the heat of the lava. These pillow lavas form these very characteristic blocks of lava, these round blocks of lava that geologists have been aware of for many years, but didn't know how they formed until people started diving on the active lava flow.
Some eruptions lie far beyond the reach of the scuba diver. This is the most extreme expedition in the world, the only way for scientists to reach the Earth's newest volcanoes. This submersible is built to withstand the tremendous pressures of the deep ocean. It's also designed to protect a three-man crew from temperatures of over 400 degrees Fahrenheit above Hawaii's youngest volcano. The Luihi volcano, 25 miles south of Kilauea, is still 3,000 feet below the waves. Down here, the steaming volcano spews out a mixture of toxic gases straight into the cold ocean.
The Luihi submarine volcano has become one of the most important natural laboratories on Earth. It's an active volcano. It's the next island to rise. It's only 1,000 meters below the surface. It has extensive hydrothermal vents. And it is within 12 hours sailing distance from Honolulu. So you can do research, you can take samples, and you can bring them to a laboratory and land within 12 hours.
Professor Malahoff and his research team are studying how life can survive in this extreme environment. These drapes of filamentous bacteria hang down above the hydrothermal vents in temperatures as hot as 450 degrees Fahrenheit. At this depth, there is no light for photosynthesis. The bacteria have adapted to consume poisonous chemicals and convert them into energy. These conditions might be the same as those found at the very beginning of life on Earth, when bacteria first appeared 3.5 billion years ago.
Life began on Earth in an extreme environment, primarily because the Earth was extreme. It was hot, probably acidic, probably either ultrasaline or It, of course, was subjected to steam. So these sort of environments we go to replicate the beginnings of the Earth. That is why we're interested to see what kind of microorganisms have survived in this type of environment.
Now Malahoff and his team want to discover if this primitive life will adapt and survive when Loihi eventually rises above the ocean. This might well be the closest environment to primeval Earth we will ever find. This is White Island, 43 miles off the coast of New Zealand. Professor Malahoff's quest to understand the origin of life has brought him here, to one of the most hostile places on Earth. White Island rose up from the ocean floor, and it boasts the most acidic crater lake of any volcano in the world.
When I walk around the White Island, I see the beginnings of the Earth. Because when Earth first formed, you had volcanoes, eruptions, you had steam, you had exactly the sort of phenomena that you see now. And of course, that's how life formed in these extreme environments.
White Island is extremely explosive. This is the first time that scientists have mounted an expedition to sample the acid lake for life forms. A recent landslide breached the crater wall, providing scientists with a way down to the steaming lake. Like the hydrothermal vents at Loihi, it seems impossible that any life could survive here. The water is not only boiling hot, it's full of sulfur dioxide fumes, giving it the pH of battery acid.
What we found with the microorganisms is that they will always push the limit, that there are special niches around, especially in the extreme temperature, extreme acid, extreme salinity, extreme depth, that they crawl into because it's a niche in which they can survive and predators can't follow them there.
Only by taking risks in an extreme environment like this will scientists ever be able to understand how bacteria originated on Earth. The initial results are encouraging, but it's still too early to know exactly what life does exist in White Island's acid lake.
I don't want this to blow away.
Just 6 months after this expedition, White Island exploded. The eruption was so violent, the entire lake was blown into the sky. It doesn't exist anymore. White Island lies at one end of a giant ring of fire, a chain of volcanoes 18,500 miles long that surrounds the entire Pacific Ocean. Every volcano on the Ring of Fire is an explosive volcano. Some of them are constantly active, but others store up their energy until they erupt with tremendous, by some standards, it's puny. This is Kilauea, on the Big Island of Hawaii. It's the largest and most active volcano on Earth. This volcano produces more gas and erupts more basalt lava than any other. As quickly as it started, the eruption begins to die down.
We are just reached the end, and the tephra cloud reaches several kilometers high and is being transported by the wind over the city surrounding Etna towards the northeast side of Etna. And the eruption now, as you can see, is suddenly dropping after the paroxysm, And we may expect a series of powerful explosions when the conduits become cleared and blocked with lava blocks and cleared again and so on.
"40 minutes after the first explosion, the eruption is over. The pressure underneath the magma has eased and will take several days to build up again. It has built the island of Hawaii, the biggest single structure on Earth. It rises 32,000 feet from the floor of the Pacific Ocean. Kilauea is also the most studied volcano on the planet, the ultimate natural laboratory. The river of lava that flows beneath this crust, fortunately, the wind dispersed the tephra cloud, and the lava flows didn't reach the lower flanks of the mountain. This eruption didn't threaten any of the towns or villages below. System Poseidon is pleased because their forecast was accurate. Etna may be Europe's largest volcano,